Let's come for. So the next one is the internal energy of a gas. What is the internal energy of a gas? So I need not to describe much, no? So already we have formula. So in what form the intention of gas will be according to KTG? Only in the form of the translational monoatomic gas will be only translational, diatomic gas will be both rotational as well as the translational kinetic energy, only in terms of kinetic energy of molecules. And that intensity of gas, the symbol denoted is U equal to NFR T by 2. For a given gas, U is directly proportional to temperature, because always I'll go for a gas now. I'll not change the amount of gas. So therefore, for a given gas, the intensity will be directly proportional to temperature. What is N? Number of moles. What is F? Degree of freedom. R, universal gas constant. So like this we define. Now here regarding the internal energy, we'll call that as a state function. It is a state function. What do you mean by it's a state function? It depends only on temperature. It depends only on, so don't write anything like a CV, like in books they're given NCVT. I'm trying to avoid. Let it be NFR by 2 or any other formula. The other formula will be NR gamma minus 1 T. Okay, let it be. So delta U will be NR gamma minus 1 delta T. So first important point, it is a state function and independent of path. I'll explain later on in the end. I'll take example. What do you mean by this one? It depends upon the initial and final temperature. Suppose there's a PV diagram. Okay, the gas has undergone a process. Next question, sir. What do you mean by process? Is it okay? So no. Let me write it. There's a pressure. There's a volume. A, B, or say like a 1 and 2. This is called like a process. So what is that line? The gas will undergo a process here. So what do you mean by this? Or else I'll do one thing. We will take the, this will be much easier. So what do you mean by here the process? The gas will undergo a process 1, 2. There's a meaning of this one. The gas will undergo a process 1, 2. So what do you mean by this? So I will take a cylinder. Let me bring nearby diagram, all the thing. So this is cylinder. Say the total, this is a cylinder. So this is having n moles of gas. It was having initial pressure P1, initial volume V1, final pressure P2, final volume V2. So this a gas is present. So initial pressure is P1, V1. So what I do, I'll make it to undergo process. Okay, what do you mean by process is what we should define it here. So both the pressure as well as volume of gas, I'm going to increase it. So who will do that? Let it be external agent. So now, shall I say gas has undergone process. So how did it undergo? Suddenly, no. Gradually, it will move from rest to rest, rest to rest, rest to rest like this. So this is called like a quasi-static, and it's a reversible. What do you mean by reversible? There won't be any resistive forces. It can again means if I move the piston back, again the gas what happened will acquire its initial quantities. Means what was earlier pressure P1, V1, what was earlier temperature T1. So can we say anything about temperature T1, T2? So let's use the P is equal to say like this is theta alpha V. So where tan theta is equal to some alpha. I think this is slope, no? It will be. And then P1 V1 alpha V1, P2 alpha V2. Let me write first. Okay, this will be nRT by V. So as volume increases, temperature will also increase. So therefore, the temperature of gas here is how much? T1. Temperature of gas is T2. It is proportional to this one. Okay, let's not bother all this. So what is the process here now? I made the gas to undergo some process, some changes I'm bringing. What do you mean by process? Where some change in parameter of gas will occur. What are the parameters of gas? Pressure, volume, temperature, energy, heat absorbed or heat relieved or work done, all the quantities. That will become as what all, they'll become parameters of a gas. So what do you mean by process here? Where the parameters of a gas undergo a change. So that's called like a thermodynamic process. The gas is undergoing thermodynamic process. So immediately what should flash for you? The gas is undergoing some changes. So what are the changes? It can be change in volume, temperature, pressure, energy, work done, heat exchange. So there is everything is called like a process here. Okay, fine. So now what is the energy of the gas now? So we should write it as nr gamma minus 1 T2 minus T1. So how that temperature varies, we need not to bother. Will it varies? This one we need not to bother. It only depends on initial and final state. So I'll bring that. It's a state function. No, what is the meaning of that? Thermodynamic process. Shall I? Is it okay, all of you? Thermod and the gas is undergoing thermal process. There's one two is called as the path. What do you mean by path? Where along the path, the pressure and volume or pressure temperature or volume temperature, they'll be related by one specific equation. You see that one along the path, pressure directly proportional to volume or temperature proportional to square of the volume. So like that, what happens? Some relationship will be there. The gas is said to undergo a thermodynamic process here. So how do it, piston is moved? Very slowly. So we say quasi-static. What do you mean by quasi-static? The process that will occur gradually, step by step. That's called like a quasi, not sudden. There's the one thing. Next again, it's a irreversible. Sorry, it's a reversible. What all we do is reversible. Means again, if I bring back the piston back to this original position, so what we'll get? Again, we'll get same pressure, same volume, same temperature. That's called like a reversible. I will explain that also. In book, everything you have this in the form of a theoretical. I'm trying to give some picture form. So what is this? This is a path 1, 2. Okay, I get this one. So this called like a reversible. Say it has undergone some process. Again, what happened? I can reverse it. This is practically not possible. We are discussing ideal case. So what's happening the gas now? It is undergoing a process, thermodynamic process in which pressure, temperature, volume, or the energy, all things are changing here. And it's undergoing quasi-static. Quasi-static is not a process. Every process will be reversible and quasi-static. That's what our assumption. So shall I say that due to thermodynamic process, what will happen to gas? Its state will change. No, it was having some pressure, volume, temperature. Now look at that too. It is having different pressure, volume, temperature. So therefore, when a gas undergoes thermodynamic process, what will happen to the state of a gas? It will change, or what will happen to parameters of gas will change. And how it will undergo? Gradually, quasi-static process, and it's a reversible. I can bring it here. Okay, now it is a state function and independent of path. It depends only on initial and final state is there. So now let me do one thing. Okay, the same thing we have took the process here. So let me take another. pressure, volume. There's a process A, B, C. What do you mean by process? Different path. We'll call it as process here. And now, how I'm moving piston? I'll move piston in such a way that pressure will be directly proportional to volume. See, you have to come out of bookish world, huh? Because in chemistry you just study okay all these graphs something. In physics, every problem. Huh? So what is this, sir? What is this? You are writing. There's a piston. All of you know piston. There's a cylinder. Nowadays, I think to fill up air in balloons during birthday parties, we do get that pump, no? So that is what I'm discussing. Of course, plastic. So you better pick up the iron one or even let it plastic. That is what you can move that piston up and down or right or left. So when you do like that, what happens? You are doing some process here. The gas here undergoing some process. Now, if I move piston in such a way that I can move piston in such a way that where pressure be directly proportional to V, then the gas is said to undergo a process C. No. How do I move? I'll move piston in such a way that where pressure and volume they're related by this equation. So shall I say some parabolic? What about here? The piston is moved in such a way that where the pressure will be related by this equation. I think this will be parabola also. Parabola, this will be positive, this will be negative slope, positive slope. Can I move? So how do this such a different process can occur? It all how you move the piston. By moving piston in different manner, we can make pressure and volume to vary linearly, path A, to vary parabolically, find P equal to alpha V square, something like that. Here what happened? P equal to alpha V minus beta V square. Getting this one. So the path will come like this here. So what's happening to gas now? It is undergoing different path now. The path is different. Means the way how I move piston will be different. Because of that, the relation between P and will be different. Are you getting no? So sir, how you can write the same given gas, the same hydrogen gas, 10 moles of hydrogen gas. I can make pressure and volume to vary linearly, to vary parabolic, or to vary inverted parabola like this here. So what's happening to gas? Undergoing different process, no? But what about initial and final state are same? The initial and final state are same. So what happens to internal energy? So internal energy depends only on according to the formula. First for the E, N R gamma minus 1, T2 minus T1. For the path B, NR gamma minus 1, T2 minus T1. For path C, NR gamma minus 1, T2 minus T1. So with this, anybody, can you say anything about change in energy for all this path? So therefore, what does it mean? Independent of path. Therefore, change in energy. Yeah? Change in internal energy independent of path and depends only on initial and final state. So how the gas is made to undergo different process by moving piston in so like by moving piston in different manner. So here, so the gas is made to undergo different process A, B, and C by moving piston in different ways. Means if I say like able to understand, I think if you can understand this, it'll be very easy for you. Because see in books we have only this diagram. Students they don't know sir why the gas will undergo. by moving piston in different way. There's a core idea. So every problem, what is the background? Background, what you should have? You should have a cylinder and there should be a piston, there should be a gas, finish all. Every problem, background, this thinking should be there. Huh? In every problem, this background thinking should be there. So there's a gas, there's a conducting cylinder, conducting non-conducting, and there's a piston. And we are going to move a piston. So fine, able to understand. So the intenji, what will happen? The change in intenji depends only on initial and final state. It is irrespective of how that, what is the process that is undergoing. We need not to bother. So this is about the intenji. So I'm using word independent of path. Okay, let's come back here regarding, sir, what about the heat energy? Well, it depends on path. You didn't say anything about that one here. So regarding heat energy also, I wanted to check whether it depends on path or not. So for that, let's take example. Heat energy, will it depends on path or not? We'll take example. So now we know how to supply heat. We know how to supply it. So here, let me come back. I'll start here now. I'll take a container. I'll fill up some n moles of gas. I'll supply heat. So how to supply it? Then what this gas will do? It's a rigid container. And I'm giving plain diagram. It's a 3D diagram. It should be temperature T1. This is T2. I'm supplying heat to this. It's a rigid box. Rigid means, what does it mean? The volume will not change, no? So now volume of gas will be constant. So now it was initially pressure P1, final pressure P2. So what this gas is doing, it is absorbing heat at a constant volume. So therefore now heat absorbed by the gas is equal to N. So this molar is specific heat capacity, I'll write CV dt. So look at that molar heat capacity. Now it will have some value called as a CV. So what is happening this one? So what is CV? You should call it as molar specific heat of gas at constant volume. Similarly, I can supply heat to a gas in such a way that it can absorb heat at constant pressure. Sir, is it possible? Yes, it is possible. So it can supply it. So how to make the gas to absorb heat at constant pressure? How to design that one? So we'll do one thing. For everything I'm giving example. No? What you studied theoretically just mere equations here. Everything is what you can have imagination in front of you. In spite of this, if you don't understand, there's some problem with your brain. Because more than this, there won't be any possible things to explain further. Huh? Okay, I'll supply heat. The gas is at temperature T1. Okay, we know some atmospheric pressure force and P into A, volume of gas is V1. I'll supply it. Then are you seeing the piston has rised up? The temperature T2, volume V2. Now, what are the forces still that is acting? mg, atmospheric pressure force, and the pressure of a gas. Now you can ask questions, sir, why you are not changing the pressure of gas? Okay, let's write equation. PA minus P naught A minus mg equals 0. Look at pressure of gas. Is it constant or variable? P naught constant, M constant, G constant, A constant. So pressure of gas is constant. Now I supplied it. So the gas will absorb it at constant pressure. So therefore, what is Q equal to NCP delta T? It is absorbing it at constant pressure. How do you can make pressure of gas constant? There's a mechanism. So therefore, now what is CP? Molar specific heat of gas at constant pressure. How this Cp and Cv are related by Mayer's equation. Cp minus Cv equal to R. And gamma equal to what? Cp by Cv. Like this, we had all this setup. Okay, now able to understand now? So like I'll supply it where the pressure volume changes. In that case, you write only this much. So what are the possibilities here? If volume constant, if the gas absorbs it at constant volume, write equation in this way. If the gas absorbs it at constant pressure, write this one. If both pressure volume changes, then write equation this much only, Q equal to NC. And that C one have to determine. So what are they? There will be three possibilities will come, no? Three possibilities will come. Pressure will be constant, volume will be constant. So therefore, this particular molar capacity, will it depends on path? Yes, it depends on path. So how do you can see? Okay, let's come back to here. So shall I slide down? So I'll write it. Gas absorbs heat at constant. I think it's understood. Everyone knows this. Shall I scroll down or I have to explain further? No need of further description. CP, CV. I'll scroll down here. Yeah. Okay, now I'll say that this molar, this Q depends on path, I'll say. Intensity, I said, change in intensity is independent of path. Molar capacity depends on path. Means here, what is the process it will undergo? Where pressure and volume are changing, no? It will have one molar capacity. Here our pressure, P equal to alpha V square something, equation will come. What about this? P equal to alpha minus alpha V minus beta V square. The equation of that particular kind, it will come. Agree this? So therefore, for different path, the molar capacity will be different. Similarly, what will happen to the value of Q will be different here. So therefore, now molar, the heat exchange. So Q A not equal to QB not equal to QC. So heat absorbed by the gas in different path will be different here. So therefore, shall we say more the heat exchange is depends on path? Will agree this? Heat exchange. Heat exchange means Q. Heat exchange Q. Depends on path. So like this what happen, we have idea of now Q and delta U. Okay, let's go for the next one. The work done. Already you have background fluids. That is what you have to take LPS. So what is the